Hi guys, again I hope you guys enjoyed the introduction to geology in the previous lecture. So this is going to be the second and final lecture for chapter 11, and here we're going to be going over the second component of the geology chapter where we go over minerals and mining. So mining, broadly defined, is a systematic removal of rock, soil, or just about any other material for the purposes of removing that material to access minerals of economic interest, which are usually going to be underneath. Now, the most commonly mined minerals are sand and gravel, and that's for the purposes of construction, the formation of concrete, for creating asphalt for roads. Sand and gravel are going to be by far and away the most commonly mined minerals. However, we're also going to be mining for minerals such as fossil fuels, so coal, oil, natural gas. And now we don't actually go over this within the context of these slides, but when we're mining for metals, typically we're not going to get the metal in a very pure state. Normally what we get instead is something called metal ore, which is an impure form of a metal, basically where the metal is fused to different impurities associated with it. How we extract metal from metal ore is essentially what we do is we bake that metal, we heat it up in some sort of blast furnace, and usually what that does is the heavy metal melts away and falls underneath, in that way it allows us to remove all of those extra impurities from that ore and extract the pure metal underneath. Now, this process known as smelting can be a little bit economically viable. However, it can be environmentally a little bit costly. A lot of those impurities can cause a form of pollution known as mine tailings, and it can cause a form of air pollution, and once those tailings settle out of air suspension, they can wash into waterways and they can cause a lot of different toxic problems. So again, that's not necessarily something we go into in any real detail, but a couple of questions I just put on your quiz, so on metals and smelting and tailings. So again, just read that small chapter or that small subchapter within your book and you should be just fine. Just a few extra couple of questions. Now for the remainder of this lecture, it's going to be kind of brief. We're going to be going over the intricacies of each different mining method that is listed in your book of any real significance, and some of the pros and often a lot more of the cons associated with each of these different mining methods. The first that we're really going to talk about is something called strip mining. Strip mining is basically removal of entire layers of surface soil as well as rock at very large areas to expose a mineral or a resource underneath. And this is probably the most common method when we are looking to extract minerals that are very close to the surface. Basically, some of the drawbacks here is something called overburden. Overburden is the overlaying soil and the rock that is removed from the area to expose the resource. Once that overburden is removed, it can cause some serious issues. Occasionally, when we are removing that overburden, we can destroy huge areas of natural habitat. And then when we move the overburden somewhere else, it also adds an additional impact to wherever we put the overburden at. Now, there also is an issue associated with acid mine drainage, and this is going to be something that is associated with a lot of different forms of different methods of mining. You're going to see this a lot. And acid mine drainage essentially refers to the rainwater mixture, or the process of where rainwater comes in, mixes with some of the exposed rare earth metals and some of the more reactive toxic byproducts of mining, and then especially sulfur minerals, for example, and forming these really acidic compounds that will eventually sweep away as the runoff goes to a different location and have horrible adverse effects to local ecosystems and wildlife. Now, as the drainage drains into the surrounding ecosystem around it, it can cause all sorts of problems. It can really mess with aquatic habitats, particularly because fish and frogs are going to be completely submerged in all of those different chemicals. It can really ruin crops in surrounding areas as the roots of different crops will begin to absorb some of those toxic chemicals. And of course, it can ruin groundwater if it seeps into that, as well as just wreak havoc on native and local ecosystems. Now, whenever we have a resource or a mineral that is in concentrated pockets deep underground or in long seams also deep underground, the most common method to extract that form of mineral is going to be subsurface mining. In subsurface mining, shafts and tunnels are excavated deep into the ground in order to access the resource. Normally here we're going to be digging a network of tunnels systematically to remove the resource and ship it to the surface. Basically, we're going to be going straight down, so we're going to have a vertical tunnel, and then we are going to go horizontally in order to access the different seams of the different resource that is deep underground. And this is very useful for some of the different minerals that we can only find deep underground. So any kind of metal, be it zinc, lead, nickel, gold, copper, and uranium, these are all going to be occurring very deep into the Earth's crust. It's going to be very hard to access by any other means of mining, and so subsurface mining is the way to go. Here, it's also useful for mining coal, particularly coal seams that are deep underground. Remember that coal and every other fossil fuel gets buried over time. It was originally formed from different organic activity that occurred at the surface millions of years ago, and then it basically got buried. So you're going to see coal being mined via very different methods depending on where the coal is occurring. Sometimes it can be brought to the surface in the case of mountaintop removal. We'll go over that in just a second. But often it's going to be in these seams underground, and the only way to really access it is using subsurface mining or occasionally strip mining if it's brought really close to the surface. Now, the impact of subsurface mining is pretty substantial. Long-term damages particularly are underground fires, especially in the instance of coal. When you are having the long shafts drill in, you're exposing the different pieces of coal to oxygen. So if you have lighting that sparks, for example, all of a sudden a huge underground fire can form. And as long as you have enough coal, which usually is a lot, and as long as you have readily available access to oxygen, that fire can burn for years. Entire towns have been completely evacuated, and they are no longer inhabitable because there are fires that have been burning underneath them for at least 30 or so years. So it can be insane. Acid mine drainage is also a severe problem with subsurface mining, particularly because when you are doing subsurface mining, you are very, very close to the groundwater. So whenever rainwater gets into a subsurface mine, it basically reacts or interacts with the mineral that you're exposing, as well as some of the byproducts, so that's sulfur dioxide, for example, and then it will essentially seep directly into the groundwater, especially when you are that deep into the ground. There's not that big of a membrane or a barrier between where the mine actually is and where the groundwater actually is. So this can be a particularly big problem here. So then usually when you have a mineral or a resource that you want to extract that is pretty much evenly distributed in the ground below you, or when you have minerals that are occurring in seams, kind of like with subsurface mining, but the ground is so unstable that it's really not going to be a safe method to actually drill those tunnels, the way to go is usually going to be open pit mining. Whereas here, instead of doing all those intricate tunnels, we are literally going to just be digging a massive hole in the ground and removing all the desired resources that we come across. So here you are basically going to see like a stadium-sized hole just carved out of the Earth's crust to basically access these minerals that are in the ground. And this is commonly used to extract things like clay, gravel, sand, and stone minerals, things that aren't really going to be in like seams or in like really high dense concentrations. They're going to be very evenly distributed across the ground. So we don't really need to dig in any specific way. Just kind of excavating everything that is out of there is a very common method to extract these minerals. It's also a primary method for extracting copper and iron ore. Again, copper and iron ore are pretty much evenly distributed in some of these areas, and so by just digging a giant pit and removing everything out of it, that's normally a very easy way to access these minerals. Now, habitat destruction is immense when we do open pit mining. Remember, we're literally we're destroying everything near it. So not only is the open pit itself a source of habitat destruction, but normally the roads and the different areas around the open pit where we are actually processing some of these ores via smelting, blast furnacing, or any other shipping methods, we are also going to have a substantial amount of habitat loss directly around the pit as well. So these can be huge areas of habitat loss and habitat destruction. So perhaps one of the most depressing forms of mining is actually going to be what's called mountaintop removal, and you probably heard about this just a little bit because it's very commonly practiced in the Appalachian Mountains. Basically what's going to happen here is, remember how we talked about in most cases some very rare earth minerals, and particularly coal is normally buried very deep underneath the earth, and so the only way to really access it is occasionally open pit mining when we just want to remove everything, or far more commonly we have to build these or dig these very intricate tunnels, which can cause all sorts of problems in and of itself. However, mountains are really unique, but because of plate tectonics, they have kind of brought material that is buried deep into the ground actually into an area that is high in a mountain where it's readily accessible. So in mountaintop removing, basically we are removing removing mountaintops. We are blasting several hundred vertical feet of a mountain across, and we are completely blasting that away. So instead of having this enormous mountain, we've completely cut it down, and we are exposing a resource. This is normally used to get coal. It's primarily almost always used to get coal, especially in the Appalachian Mountains, but occasionally it's also used to extract precious metals. The impacts are probably the most severe with mountaintop removal than any other form of mining that we've talked about thus far. Forests are entirely clear-cut. The topsoil is completely removed. The mountain is completely removed. So we no longer not only do we have the ecosystem, but we no longer even have the landscape that ecosystem was on. Unstable rock as a result of mountaintop removal causes landslides and flash floods that destroy nearby ecosystems. So the area of impact is just immense, and it degrades huge amounts of habitat. And then just like every other method of mining that we've talked about, acid mine drainage is a really big problem with mountaintop removal, particularly because mountaintop removal occurs on a high elevated area, and so runoff can flow down the mountain and impact areas and ecosystems that are very, very far away from the actual incidence of where the mining took place. One of the other major forms of mining, or not major forms of mining, but mining that's practiced fairly commonly in impoverished countries, is something called placer mining. And placer mining is basically sifting through riverbed material and running water to expose precious metals. Occasionally, precious metals are eroded out of the side of the riverbed and the floodplain simply because of erosion. So basically, as the water sweeps away the sand covering up different precious metals, the precious metals are exposed. And so you see this practiced a lot in impoverished countries looking for things like diamonds, gold, and other precious metals and precious materials. This is usually pretty small scale, and the impacts are actually pretty minor. So this is one of the better stories, especially in direct contrast with mountaintop removal that we just talked about. Usually the only real impacts are debris left in riverbeds and streams, as well as a little bit of erosion on the shoreline. But again, this one is far more minor compared to the other large-scale forms of mining that we've already talked about. And there are some specific actions that we can take to extend mineral resources, particularly so that we can minimize the impacts that mining takes place on our local ecosystems. The first is discoveries of new resources. So this one is one of the methods that actually exacerbates problems with ecosystems. And here you're going to have things like offshore drilling, where we are running out of oil in the terrestrial systems. So we are now taking advantage of the enormous reservoirs of oil and natural gas that are off our coasts. However, this can cause some serious problems, namely the Deepwater Horizon oil spill that happened in 2010 that just had a whole host of different problems. Another method are better extraction technologies. So by having access to previously unextractable pockets of minerals, we expand our available use of mineral resources, and this can also happen in areas that are already degraded, so there is the benefit of not impacting any additional ecosystems. Instead, we just go back in what's called secondary extraction, something that we're going to be talking about in the non-renewable resources chapter of the next module, where we simply go back to old mines and using better technologies extract additional resources that weren't available to us before. Finally, perhaps the most encouraging pattern and behavior that we can use is changing our consumption patterns and then recycling. So most metals can be recycled for a significant amount of time, not forever. Every time you recycle, melt something down, you degrade the mineral a little bit more, unless it is a very robust metal. But it does very, very, in a very broad sense, largely conserve our finite amount of metals and precious minerals. And by recycling and by conservation of what we already have, we delay the need to extract additional methods from additional mining, and we also maintain our reserves of finite non-renewable resources. And then finally, something that I want to talk about just briefly is something called reclamation. We talked a lot about the ecosystem destruction and impacts related to different mines. So the act of reclamation is essentially the act of restoring ecosystems that have been previously impacted by different mines. And essentially, we are trying to return them to their pre-mine conditions. Basically, here we're going to remove all of the different mining structures. We're going to fill the shafts, and we're going to replace the overburden. So all the material that has been removed from that area is then returned. We replant native vegetation as a way to basically rebuild that ecosystem. And it's getting, in most cases, we are getting better at our ability to reclaim ecosystems that have been damaged by mining. But acid mine drainage is still a major issue in these areas just because of all the exposed sulfur and other toxic chemicals that are associated with the mining process. So that is everything that we have for Chapter 11. I know that the mining section was a little bit depressing, but I do hope you enjoyed and found this chapter interesting overall. I can't wait to talk to you about the water and water ecosystems generally in Chapter 12. Chapter 12 has 5 different PowerPoints, and all of them are very interesting in and of their own right. And I look forward to talking to you about all of that in the next lecture. All right, see you later.